All right, this time we're going to look at a grouped frequency distribution. Sometimes, if we want to use a frequency distribution to represent or to present data that doesn't have a lot of repetition in it, right? When we looked at the frequency distribution, we had a bunch of ones, a bunch of twos, a bunch of threes, and not terribly many different responses. Here we have a whole bunch of different responses. These kind of look like grades. They're just made up, but they could be grades on a test. And I'm not going to use a frequency distribution and have a row for 65, a row for 70, a row for 72, etc. That would just be unwieldy. So what we're going to do is, as you would expect, we're going to put these into groups or categories. And if we're talking about grades, we're going to talk about 60s, 70s, 80s, 90s. So instead of listing single things over here, we're going to look at a group of grades. So in the 60s, anything from 60 to 69 will be in our first row, 70 to 79, 80 to 89, and 90 to 99. Now, of course, in reality, most teachers do their grade books. This last one will be 90 to 100. That's not really 100% kosher because that makes this one wider category than the others. These each have only 10 numbers in the category. This one would have 11 if we included the 100, and that's why I scratched it off. I didn't want to deal with it. Not really. We just deal with it by putting it in there and just accepting the fact that it's not 100% kosher, but we don't have to always be 100% kosher. That would count how many are in each category. Right? There's 1 in the 60s, 1, 2, 3 in the 70s, 1, 2, 3, 4, 5, 6, 7 in the 80s, and then 1, 2, 3, 4 in the 90s. For the record, I would be very happy with that distribution on a test. I know a few people would not be very happy, but overall, I would be pleased with that as a distribution. We get a total of 4 plus 7 is 11, 12, 13, 14, 15 again. That's a coincidence. Happy coincidence, because that means the math is going to be easy for me. And we're going to look at the relative frequency distribution also. So not how many people scored in the 60 range, but what percentage of students scored in that range. And you remember from the previous one, if we divide 1 by 15, we get 6.7%. 3 divided by 15 was 0.2, which is 20%. We'll have to check on these guys here. It's real easy though, just 7 divided by 15. And that'll give us 46.7%, which is almost half of the class. And that seems right, 7 out of 15. And then 4 divided by 15 for the A's gives us 26.7%. Now you can double check me here. You don't have to. You can take my word for it that if you add these up, you do not get exactly 100, right? 7 plus 7 plus 7 is 21, which means we're actually going to have a leftover 0.1 here. So what we're going to need to do is just choose one of these guys to mess around with. And instead of having 6.7, just say, I need to get rid of 0.1. So I'm going to take the 0.1 off there. And we're just going to call that 6.6. And that way, these will add up to 100%, which they need to. Right? That's a grouped frequency distribution, and it is useful, again, for when we have data that doesn't have a lot of repetition to it. So that would give us too many rows here to cut down on the number of rows. We group them together and then have a row for each group. Pretty simple concept, I think. I certainly hope so. Next time.